Solving linear systems by elimination. Our question says, solve the following using substitution. And we have the equations 11 take away 2y equals 3x, and 2x plus 5y equals 0. So linear systems are, in this case, two lines. And solving means finding the point of intersection between those two lines. So there's many different methods you can use for this. One of them is graphing. Another one is substitution. And then elimination is just another algebraic method that we can use for finding the point of intersection between two lines. So elimination, or to eliminate, means to get rid of something. So when we're using elimination, and I just noticed the question here should say elimination. What we want to do is choose either x or y and find a way to get rid of them, to remove them from the equations so that it's a little bit easier to solve. So there's a couple of steps we're going to follow to do that. The first thing I want to do is I want to take my two equations and try to write them so that they're in the same order. So I could leave the order of the first equation the same and then try to rearrange the second one to match. Or I could leave the second equation the same and try to rearrange the first one. So I think I'm actually going to leave the first one the same and rearrange the second one to match. So if I take a look at the second one, I notice that the x needs to be on the other side and that the y needs to stay here. So what I'm going to do is take 2x away from both sides to move it over to the other side. So when we're doing substitution, I would write the equation over here. But since we're doing elimination, I'm actually going to write the equation underneath this one. So if I take the 2x away, I'm actually just left with a 5y on this side. And I am going to write it so that it's underneath the other y term. And then I have my equal sign. And then 0 take away 2x is negative 2x. So I notice that I have x, I have y, but I don't have any numbers here. So I might actually write in a 0 to make this a little bit easier for me. So I have 0 plus 5y so that I have numbers that line up, y's that line up, and x's that line up. So what we want to do when we're doing elimination is we want to choose to either get rid of the y's or to get rid of the x's. So usually I look to see which ones have coefficients that are the same. And I notice my y's don't have coefficients that are the same and my x's don't have coefficients that are the same. So then what I do is I look to see if I can find one that have an easy value that they both go into. So 2 and 5 both go into 10, and 3 and 2 both go into 6. So it's our choice. I think I might actually eliminate the y's. So what I want to do is take each equation and try to multiply it by something that's going to give me the same number in front of both of the y terms. So I know that 2 and 5 both go into 10. So I'm going to take the top equation and multiply it by 5. And I'm going to take the bottom equation and multiply it by 2. Now I also want them to have opposite signs, which means I want the number, one of them to be negative and one of them to be positive. If they were both positive, I would make one of these numbers negative so that one ends up negative and one ends up positive. The same thing if they were both negative, I would do the same thing. I would make one of these two numbers negative so that they ended up with opposite signs. So all I'm going to do is multiply these equations. So I'm going to multiply the first one by 5 and the second one by 2. So 11 times 5 is 55. Negative 2 times 5 is negative 10y. And 3 times 5 is 15x. Then I'm going to do the exact same thing with the second one. So 0 times 2 is 0. 5 times 2 is 10y. And negative 2 times 2 is negative 4x. So I now notice that I have the same coefficient on both y's, except one is positive and one is negative, which is exactly what I want. So to eliminate or make these cancel out, all I need to do now is add these two equations together. So 55 plus 0 is 55. Negative 10y plus 10y gives me 0. So that's completely gone. So I can either write absolutely nothing, or I could write a 0 if it helps and makes you feel a little bit better. And then 15 plus negative 4. 15 plus negative 4 is 11x. Right? So I have 55 plus 0, which is really just 55, equals 11x. So you'll notice we've eliminated the y's. The y's are now completely gone, and all I'm left with is an x. And I can just solve my equation. So if I want to solve for x, I'm going to move that 11 to the other side by dividing by 11. 55 divided by 11 is 5. So x equals 5. That means that these two lines intersect, and they intersect at an x coordinate of 5 and a y coordinate that we haven't figured out yet. So to find the y coordinate, we have some choices. So number 1, I could take that 5 and substitute it back into the first equation to solve for x. I could put it into the second equation to solve for x. Or I could take the two equations, and instead of eliminating for y, I could do it a second time by eliminating for x, and then I wouldn't have to worry about substituting that back in. So 3 completely different options. It's your choice what you want to do. But I think what I'm going to do is pick one of these two equations and put it in. I think I'm going to take the first one, actually. So I've got 11 take away 2y equals 3x. So in place of x, we're going to put in 5. So 11 take away 2y equals 3 times 5. So 11 take away 2y, 3 times 5 is 15. And then I'm going to try to solve for y by subtracting 11 from both sides. I'm left with negative 2y. 15 take away 11 is 4. And then I'm just going to divide both sides by negative 2. And I get 4 divided by negative 2 is negative 2. So the elimination part wasn't so bad. I didn't really like having to substitute this back in and solve. It might have been a little easier if I had picked the second equation instead. Or sometimes if it doesn't work out very nicely, doing a second set of elimination but eliminating for the other letter is also a good way to get that number, right? Any of those methods would work. So I do get a value for x and y. So therefore, the solution, the point of intersection, is x, so 5, and y, negative 2. And that's solving by elimination.